Imagine you have a DeFi protocol that wants to delegate a $100,000 portfolio to an AI agent for it to rebalance. How does a smart contract know that the AI agent is not going to screw up? Again, there's no on-chain reputation, and the AI agent could claim that it succeeds 99% of the time, but we actually have no proof of this. Again, we also don't want to expose real performance data to our competitors. This is what Agent Attestation Service is solving. It gives verifiable agent credentials using Chainlink CRE and zero knowledge proofs. So let's see how it works. An agent requests a standard or verified attestation, and then a Chainlink theory workflow is triggered. It fetches the agent's performance data using confidential HTTP inside a trusted execution environment. And then a zero knowledge proof is generated. This proves that the agent has met the tier threshold without revealing the actual numbers. That proof is then submitted on-chain to our Agent Attestation Service contract, which creates a tamper-proof Ethereum Attestation Service.
So let me show you how the CRE workflow itself works. So this here is workflow A, which handles the attestation issuance to the agents. And this is the core of the Chainlink confidential compute integration. So we use confidential HTTP client.send requests, which is a CRE SDK capability that executes the HTTP request inside the trusted execution environment. The agent's raw performance data, that is the task counts and the success rates, is fetched here. It never leaves the enclave. The authorization header references a platform API key secret, which is injected by the Vault DON at runtime. In production, not even the node operator can see this value. And then once the ZK proof is ready, the workflow calls runtime.report, which is a CRE signed report, which the EVM client.write report here will commit on chain. This is the CRE pattern for trustless on-chain writes. Multi-node consensus before the transaction is submitted. So the MOOC performance API is running on port 3002, and it simulates the external agent platform that CRE's confidential HTTP would call in production. It has a verified eligible agent that is preceded already with 150 tasks and 143 successes, which means a 95.3% success rate. So let's simulate the CRE workflow using the CRE CLI. So here we're running CRE workflow simulate with the broadcast flag, and the CRE CLI will compile the workflow to WASM, initialize the simulated DON environment, and fire the HTTP trigger. So here we're going to see that the confidential HTTP fetch to the MOOC API will be displayed, and then the tier eligibility check and the signed report will be generated. So here, as you can see, the result is a success. And then the workflow broadcasts a real Sepolia transaction, and here's the transaction hash. We have the Agent Attestation Service API that is running on Sepolia, and we can create an attestation end-to-end. So in a new terminal, we're going to request a standard attestation. So here we're requesting for the attest endpoint a standard tier attestation for this agent ID, and then we can run that. Under the hood, the API fetches the performance data. It checks the eligibility and generates a real ZK proof that will be submitted on chain to our AAS registry smart contract. So the attestation has been created. It's a success. And you can see that the tier standard, we have a transaction hash. This means that now any smart contract can verify this agent. And so the Agent Attestation Service is fully deployed on Sepolia with 3 smart contracts and 4 Ethereum Attestation Service schema that are already live. And all the code is public on GitHub.